Hi, everyone. It's really great to be here. I'm really honored to be speaking with you today on behalf of Cordoba. Just to give you a little bit of context, a little bit about me before I start. My name is Michelle Casbon. I'm Director of Data Science at Cordoba. And I have a little over a decade of experience working in data engineering. And both my degrees are in computer science. Grad school was when I got started with machine learning and natural language processing. And when I was a teenager, I lived overseas for a few years. I decided I wanted to learn another language. And so natural language processing is a very good combination of my interest in computer science and my interest in linguistics. So that's what I'm here to talk to you about today. And I got interested in Spark because it's a way of enabling even better NLP. You can do a lot more if you have more machines. And I also gained a deep appreciation for emoji over the past few years. I think there are some really interesting studies that you can do in terms of NLP with emoji. So we'll be talking, you'll see a lot of emoji on these slides, and specifically emoji 1 is my favorite subset. For the past couple of years, I've been working with language technologies, so I'm pretty sure a few of my friends think I'm working on a universal translator. And while that would be pretty cool, it's not really what I'm doing. I spent a lot of time making custom emoji on our Slack channel. Clearly, I'm saving the world on a daily basis. Not really. I will be talking a little bit more about what I actually do. So in terms of agenda, what I'll be going over today is the problem of localization, why it's so important, what makes it so hard, and how we can make it easier. I'll go through a couple of examples of why it's hard and some of the problems that it can cause, and how we can use NLP to solve that problem. And specifically, I want to give you, if you're not familiar with what NLP is, or if you're a little bit fuzzy on it, I want to really take that 10,000-foot view and kind of break it down into really simple terms. So we'll go over a really quick 5-minute intro into what NLP is. And I'll talk about Spark's role in that, how it enables us to build out our platform, the type of infrastructure that we're using when we're doing that NLP, and how we deploy it in production. So we'll go into a little bit of detail about those. I wanted to start off with a story. So this is an Airbnb listing. This is where I live. I live here in the Mission. It's a really amazing location. It's about a 10-minute bike ride from here. I really love it. But the thing about living in San Francisco is that rent is really outrageous. So there's a couple of reasons why Airbnb makes sense. Number one, to help pay the bills. Number two, I mentioned that I lived overseas. The language that I wanted to learn was German. And so the good thing about Airbnb is that you can get people from all over the world. You can keep your language skills up to date, and you can keep up with what's going on the other side of the world. So those are the three reasons why this makes sense. And my version of my listing looked very appealing, and I got a lot of Brits, a lot of Australians, and a lot of Americans coming to stay with me. But I didn't really get many Germans, because this translates to, diese Wohnung befindet sich an einem mörderischen Standort. Mörderisch means the same thing in German as it does in English. And I was essentially advertising an apartment in a dangerous location. So this is why localization is so important, because if you make mistakes, then it can really curtail your efforts to fulfill your goals, like in this case. So one of the questions that I get from everyone is, what is Cordoba? Well, it's a translation and localization management platform, and it layers on top of machine learning, and it uses smart process flows to enable companies to go international in a more efficient way. The company mission is really to see every product in every language by default. And we've really reached a point with machine learning where it's possible to do international business in a scalable way. So we're really trying to enable a fast way to go from just one market to many. I couldn't talk about Cordoba without mentioning my team. They're a really amazing group of folks. We're located here in South Park, just a few blocks away. We're a Series A startup. And one of my favorite things about the team is that we're 40% female, and we have a lot of female leaders. All the ones that are circled are in positions director level or above, which I think is really great. I love the team. It's a great place to work. So let's talk about, we've talked about a little bit about the future and how we want to change things, but let's talk about what it's looked like traditionally. What has localization looked like in the past? It involves a lot of humans. So there's a lot of communication. There's a lot of different teams. There's marketing, product managers, linguists, engineers, all these different people. And a lot of that communication is manual. And what we don't want to do is just be sending things over the wire, because we've all seen the results of this historical process. Does anyone remember this campaign from the early 90s? It was wildly successful, and it got a lot of Americans drinking milk. But a lot of the Hispanics who read this in Spanish, they didn't really get this because it roughly translates to, "Are you lactating?" And it wasn't nearly as effective of an ad. Another example is, I want you to think about, so if you're not familiar with Nicole Miller, they're a fashion company. They also do home furnishings. They have this really effective ad. In English, it's pretty obvious what they mean. There's this cultural reference, and it's immediately obvious what they're selling and what the reference is. But if you were to translate this into German, what would that look like? You might come up with something like this, which is essentially, I realize that when this telephone service flashes, it can only mean one thing, which is a much less effective ad in a different language. So we really think that there's a better way to do it, and we want to make it more efficient and more localized than it's ever been before. So really fundamental to what we're accomplishing, what we're doing, is the idea of, you can really think of us as being the Docker of content and isolating out all of the content from the application into its own separate layer. It's a central location for organizing everything inside that content layer, and it enables you to coordinate activities between those various teams, and it can improve quality and reduce cost because you're eliminating a lot of that manual repetition. And this enables the use of machine learning. So this is how we're able to apply machine learning. So you have your content layer all the way at the top, and then beneath that is your application. That's your application as you think of today, all the business logic. Below that is your Docker layer. That's where you're containerizing everything. And then beneath that is your virtualization layer, or your bare metal. So content is really just completely separate, apart from everything else. Some of the biggest problems with localization as it exists today is content in most applications is just really deeply embedded. It's kind of everywhere. And the solution to that is really just to containerize it, to put it in its own separate layer, and to keep it completely separate. The other problem is that the same strings get translated over and over. You might have many different linguists on a project, and they might not realize that one has been translated. The solution to that is really to have something called a translation memory, so that when that string comes up again, it's just automatically populated and no one has to think about it. You don't have to waste time on it. And that's also how we are able to do, the machine learning is what helps us, what prevents all the repetition. It makes it really simple and straightforward. Another common problem is that translations can be wrong, and if it's wrong in one place, then it's wrong in a lot of places usually. And with machine learning, that's kind of, if you have your strings indexed and completely separate, that's pretty trivial. And if you have new content that you're adding to your application, that can take a really long time. But when you're using machine learning, then you can have real-time translations right away. And you can work on those later, but the important thing is that you have something right away instead of having to wait weeks or months to get your new content in another language. They also, a lot of times, a linguist will see a bunch of text in a spreadsheet, and they won't really have any context. So imagine with that Hotline Bling ad, if all you saw was the text and you didn't know that it was advertising these cell phone covers, that might be very difficult to translate. And so we have a live editor where if you're on a website, you're actually translating things as they show up on the website, and it's a lot easier. You can worry about lengths and things fit on the page easier. And then this is my personal favorite one. This is our GitHub integration. This means that when someone makes a change to that content, it's automatically flowing into the source, and you can deploy it very easily with a PR. That means that your marketers are essentially creating these PRs, and your engineering team has a lot of confidence in deploying those because they know that it's just content and it can't affect any of the business logic. That's really neat because you can integrate it into your continuous delivery systems. Well, let's look at another example. This is, so everyone, you're in San Francisco. Hopefully you've walked a few blocks away from the Moscone Center, and you've seen that if you just walk a few blocks, things have a completely different vibe. One thing I love about San Francisco is that there are so many neighborhoods and there's such rich culture in each of them. So let's imagine that you are a produce vendor and you want to start selling products. So this might be your sort of default ad. This is what you could deploy across the city. Let's say you are looking at an electronic billboard and that's your sort of default standard ad. That might work across the city, but you might want something a bit more effective down in the Mission, where there are a lot of Spanish speakers, where the weather is really nice, it's sunny, people want to eat a lot of watermelon while they're in Dolores Park. But that might be a lot less effective in Chinatown. Obviously, you'd want to have something in a bit more appropriate language capacity, and the watermelon that they expect might look a little bit different, and the same in Japantown. So those ads would look very different. And if these are just 3 neighborhoods within one single city. If you extrapolate that out to different cities within California or different states within the country, you can see how management of all of that can get pretty messy. So really fundamental to this idea is this concept of containers. And it's not just about putting different languages on things or different images. It's also about using different styles of language. So this could be different styles of English. Let's say I'm writing obituaries. I'm going to want to be using somber language, not something that comes from social media. Likewise, in social media, you don't want things that are depressing or maybe legal-based. That wouldn't really make sense. So we really want these domain-specific containers, and not just containerizing things within that content layer, but also the cool thing is that the platform is built in Docker containers, running on Kubernetes, running in VMs on Google Cloud. There's just really containers all the way down. So that's really fundamental to the approach that we want to take when we're building applications. So this is one of the things that I'm most excited about. This is a project that my team has been working on, and this is kind of the core of the NLP that I've been working on. So this is affect detection, and it really just refers to identifying the underlying emotion behind a piece of text. And it's important because it can help us with automating that process. So that can help us understand whether we want to push automatic translations through as correct or whether they throw up red flags and we want a linguist to look at them. And it also, it can really give us an indication of what that text is about, and that can come in handy in a lot of contexts. And what does all this have to do with Spark? You're all here to learn about Spark. Well, Spark is really core to the way we've implemented this. It's at the heart of our machine learning algorithms. We're calling functions in MLlib, and it's really core to what we're running. So a couple of examples, a few reasons why affect detection is so important. This is just an example sentence that we put through our affect detector. And does anyone have a guess as to what emotion this sentence might have evoked? You have a couple of choices. I don't know, happiness. Happiness is a good guess. Well, so we got kind of a surprise answer. And this is trained on a corpus of data, so that tells you something about the data that you're looking at. So we changed one word. We didn't change the language or the gender. We changed one word, and we got a very different response. And the meaning behind these two sentences is very distinct. If this is important to whatever application you're building, that could be a serious mistake, especially if it's in another language, so you really want to know about that. And knowing those different emotions can make you look at that one more time instead of just letting it go through. Another one is, let's say you're this produce company trying to sell more watermelon, and you're located in the Mission, and so you want to put out an ad. You need people, so your help wanted sign, the emotion associated with that, we got sadness because you're overworked and you're stressed out, but you're in the Mission, and so you want to cast as wide a net as possible, and your translation is something more akin to get off your lazy butt and get a job. I can't imagine that you're going to get a lot of applicants. So knowing what the emotion is can really throw up red flags. If you don't speak Spanish, you can at least say, okay, maybe I should get someone to look at my really terrible translation. And then back to our example from earlier, the emotion associated with those two is so different. That's the perfect example of where if you had translations going through your system, you would definitely want to flag that one. That's why affect detection is so important. So this is what we set out to build, this affect detector. And what we had to do, we had to fit it into the existing infrastructure. So we have a really typical microservices architecture, the broader Cordoba platform that organizes all of this content. It's your standard, we're a Scala shop, so it's all a Play framework, sort of REST interface. And the affect detector is really just one other service. So we wanted it to be able to communicate with all the other services and just be available for anyone to get predictions from. And it had to be fast because it's a web app. And it needed to scale, obviously, in terms of machines, but also in terms of the number of languages that we support. We had to be able to build hundreds, if not thousands, of models, and then also be able to have it part of our continuous delivery process. All of these things had to be accurate, or it's not useful. And we really cared about it being open source, not just using open source tools, but also being able to open up our code base. Because the thing about NLP is that it's really versatile, and there are lots of different pieces that are useful in other contexts. So, for example, part of this process, we need a tokenizer, and we're working in all different languages. So, if anyone's tried to find an Arab tokenizer, they're pretty terrible. And so if we have a really good tokenizer, we want to put that out there because it's useful for so many other things, and it really helps further our company mission, even if it's not us doing it. So open source was important. Now, with all those requirements, what did we decide on? We decided on Prediction.io, primarily because it provides a lot of the functionality that we need, a lot of the glue, without us having to do a whole lot. So within 24 or 48 hours of looking up Prediction.io and installing everything and trying it out, I was able to create a classifier that would give me predictions. It could tell me which Simpsons character had said a given quote. And that may seem unrelated to affect detection, but it's really just another form of a classification problem. And you're probably all familiar with this slide, but that's essentially our skateboard. So at the bottom, step number 1, create your Simpsons model. And what we found ourselves doing is when we really changed that into, put in our own training data and started looking at emotions, we really found ourselves skipping over to step 3, and we had something much closer to a bicycle. And that got us there a lot quicker than if we had just built it all by hand. So that's why we chose Prediction.io. It's Spark under the covers, and it just does a lot of the really mundane tasks for us. So what exactly does that bicycle look like? Is anyone familiar with that scene in Apollo 13 where the rocket scientists get locked in a room and they have to save Tom Hanks's life, and they only have a specific number of things to do it with, and so they just sort of dump it all out onto the table? Well, that's kind of what it felt like, because there are a lot of components with Prediction.io. It's really flexible and scalable, but there's just a lot of moving parts. This is, I won't go into too much detail now, we'll go over it a little bit later, but essentially it allows you to separate your storage and your compute, and do all of your heavy NLP stuff on a single container. You can spin up as many of those as you need, and then you can just sort of send in your training data and have people make predictions. So it's pretty straightforward, but it is a lot of different components. So this is where I wanted to take a step back and go over what it is that we're trying to build and why it's so different from your standard application architecture. So NLP is definitely different from normal applications because you have these very specific steps. At its core, NLP is really just taking text and turning it into numbers so that you can do math on it. And the reason we want to do that math is so that we can identify patterns and make predictions. So there are really these 5 core steps, and I'll go over each of those in a little bit more detail. But the first step is always feature extraction, where you take your text and you turn that into some sort of numerical format. In our case, because we're using MLlib, we're turning that into a vector of doubles. Now, this is the standard, the Spark object vector, and we're giving that a classification. So for each one of those pieces of text that's turned into numbers, we give it an answer key, and that's what we send into our training function. So training is just taking that collection of vectors with all of those answers, that's a classification for each one, and fitting coefficients. So taking some sort of mathematical formula and finding a way to, given an input, spit out an output. And that's training. And then the prediction phase is where, when you give it an input, it spits out an output based on this formula that it's fit, based on the coefficients that it's determined from the training set that you've given it. And predictions are all well and good, but if they're not accurate, they're not going to be very useful. And so cross-validation is about understanding how good your predictions are, how good the models are that you've trained. And that just gives you a score. You can basically boil it down to a number or several different numbers, metrics that indicate the quality of your predictions. And if it's not what you're happy with, if the accuracy isn't high enough, that's where you would tune your hyperparameters, and that refers to tweaking a few of the inputs to your algorithm and then going through the training process again and sort of going through that loop until you have the accuracies that you need. So we'll go over each of those little steps just very briefly. That feature extraction phase, it can be very basic. It doesn't have to be complex by any means. The first thing, you just take out the content that you're interested in, and you tokenize that. We mentioned tokenizers before. That's really just taking things out into their single units, into their individual units, and you can look at single words or pairs of words that appear together, and then you just count those up, and that's how we create a vector, just an arbitrary index of numbers, one for each term, and then we increment that integer or that double every time we see one of those. So really simple, doesn't have to be complex, just creating some sort of mathematical representation of our piece of text. And then comes training. And again, this is really straightforward because we use MLlib. They do a lot of the heavy lifting for us, and they just expect us to send in a collection of vectors of doubles along with the answer key. And we literally just call that function, and it spits out a model. And with that model, we can take that same featurization pipeline, and when we get a new piece of text, it's really important that it's in that same feature space. So we run it through that exact same featurization pipeline and get a similar vector of doubles, and then send it to that model that MLlib has given us, and it will spit out a classification. So pretty straightforward. And then cross-validation really just refers to, standard is tenfold. So you essentially perform training 10 different times on random splits of the data. And you use that to look at how accurate your predictions are over lots of different samples. And that results in something that we call an F-score. That's a pretty common measure. That's what we use. And then if it's not good, you tune your hyperparameters, and you just do that over and over again. So that's basically it. NLP can get a lot more complex, but at its core, you don't really have to be doing anything really sophisticated, and the simpler you can keep it, the better oftentimes, especially if you're talking emotions and not something that has to be 100% accurate. As long as you're sort of in the ballpark, you really don't have to get too sophisticated. So this is what our stack looks like. This is the environment that we're integrating in. This is where we're putting our affect detector. It's a really, like I said, it's a really traditional microservices architecture where there's a typical front end. That's where our users access it. We also have an API. There's an orchestration layer that acts as the go-between between the front end and all of the microservices and sort of coordinates all of that. And affect detection is really just one of those many microservices. So this is what it looks like before I joined, before I decided to bring the circus to town. It was a standard Mesos cluster. Again, we're a Scala shop, so we were building things in SBT and just deploying things pretty vanilla, very straightforward. Things were running pretty smoothly. But a source of conflict in many teams can be when data science decides to just sort of dump all of these new tools into an environment and ruin the sort of happy jar existence of the rest of the platform. So for us, we were able to avoid all of that drama. The answer for us was to choose Kubernetes. And I started out by putting the affect detector in Kubernetes just on its own. And that looked a little bit like this. There were containers for each of the different components, one model per language. And it was pretty smooth. It was operating just fine. And then we just took all of the things that used to be in jars. We Dockerized those and added them to the same cluster. And voila, it was really simple and homogeneous. And it solved so many problems for us. So let's see. So the way we deployed the affect detector, this is essentially what an image looks like. If you were to do all of the entire process on just in a single container. You would load your data, you would build your objects, you would train them, and then you would run prediction. But the problem with that is that each of those steps looks very different. The predict phase is really just sort of something that listens all the time, and training and loading data, those are more batch-oriented pieces. Especially training is just much more resource intensive. So what we did is we took out the storage, obviously that's in a completely separate layer, but we used the same Docker image, and then we just added different entry points for each of those tasks, because we want to be running the same code base, we want to be using the same data set, but we want to be able to spin it up into different containers that can use different amounts of resources and run for different lengths of time. So what that looks like is essentially this. We can have containers that are just doing prediction. We can have a lot of those because they're a lot more lightweight. And then we can have some heavy-hitting training containers that are running, every once in a while. We can really control when they run and for how long. And then our data load, that's much less frequent. That's just whenever we have new data arriving. So it really just made a lot more sense to put it in Kubernetes. That image that we used looks a lot like this. So it's pretty standard. It's nothing. We haven't really done any optimization to these images. So we're just using standard Ubuntu, building everything from source, so Java 8. Building Spark from source because we want to use the native linear algebra libraries. And you don't get that if you just download the binary. Right now, we're still using Prediction.io 0.10. This was their first incubating version as part of the Apache incubator. And it didn't support Spark 2, but their new release does, and so that's kind of next on our list to upgrade to. But pretty simple, nothing crazy there. These are really fat images, but it has everything we need, and we just use different entry points. The router, that's our sort of pointer to all the different languages for the different predictors. And this looks a lot like the rest of the services. This is just a play framework, something that sits and listens for requests. And so we have this thing called a builder image, and that really just looks like it's Ubuntu, it's Java, it's SBT, it's the Google SDK, it's all of these sort of base elements. And that means that we can just standardize versions across all of our microservices so that we don't get a lot of variety. And that simplifies a lot of your Jenkins setup. You don't have to maintain things on your Jenkins server. It simplifies a lot of things. So those images are really fat, like I said. We started out by going down the inception rabbit hole of using Docker and Docker. And it did give us pretty small images, but there was somewhat of a learning curve in containerizing things. Thankfully, DockerCon, a few months ago, they announced this thing called Multistage Builds, if you haven't heard of it. It's essentially a Docker native way of doing that without having to do these complicated socket sharing techniques. So that's what we have in mind to thin out our images. And that was sort of stage one. That was our bicycle. The next phase is really for us to move into that motorcycle realm and ramp up, get something that's faster, lighter, more useful, and we have a lot of ideas for that. That's essentially adding more algorithms and finding more metrics, using, this wouldn't be an NLP talk if I didn't mention unsupervised learning. TensorFlow is also something that we're looking at. And Weaveworks is a really cool tool for deploying on Kubernetes. If you haven't looked at it, it's definitely worth looking at. I'm kind of running out of time, but essentially we talked about what localization is and why it's so important, how NLP can help that, and why Spark is so central to that, why it's really the core, it's really at the heart of the algorithms that we're using, and how we deployed that, and how we can sort of maintain peace between data science and engineering. So I wanted to leave everyone with a challenge. When you're building your applications, even if you think you'll never go overseas, it doesn't really matter, but by just separating your content out into another layer, you can really save a lot of time and maintenance and headache, especially later if you do want to localize. So my challenge is really, we're all here because we use Spark and we're building things that scale. My challenge is not to just build products that scale, but to build products that also scale content. So I'm not sure if I have any time left, but if you have any questions, that was all I had.
Thank you, Michelle. Anyone has any questions? We have about 10 minutes, so.
Thanks a lot. Great talk. So earlier on, you had shown some of the challenges in doing the translation. This isn't really Spark or infrastructure so much, but one of the things was an advertisement for something about a hotline where it became clear that sort of almost being witty and having a little bit of that sort of poetic thing, I don't see how maybe even Word2Vec couldn't even capture that. Like what are you guys thinking of to try and capture that sort of subtle marketing aspect, I guess?
Yeah, so I think it's less about being able to automate that because there is so much nuance to it, and it's a temporal cultural reference that may not even be relevant next year. I think our focus is less on coming up with these witty equivalents in other languages as really just highlighting it as like, hey, there's this machine translated version, but you shouldn't use it. You should take another look at it. And so it's really about automating as much of that workflow as possible, but not doing everything. There's still going to be a lot of humans involved. And without humans, it's never going to be an effective ad. So really the idea is just to make it more efficient for humans to come up with it, because I think that's a very creative role.
But like the emotion wasn't different. Would it be captured on this? I guess that was my question.
I think the emotion would be fairly different between that sort of bland telephone service one. It might be different. Affect detection is definitely not the only machine learning that we have in our system. And we have something called Smart Suggest where we have a lot of things that kind of build on top of each other. And this is one component of it. But that's why we're always looking for new things to add to that as flags, as input, to give teams analytics so that while they're managing these projects, they may have thousands, hundreds of thousands of these strings. So to try and flag it. So emotion may or may not have captured it, but it's a good point.
Thank you. Here. Thank you for the great talk, women's style, really enjoyed it. Have one question, probably one comment. One is about the sentiment analysis. Since you have a text and you try to detect it's negative, positive, or neutral. So just wonder what kind of training data you use, given the examples you use is very short.
I'm sorry, what was the question? What
kind of training data you use to train the system?
Yeah, actually, I'm not sure why that slide wasn't in here, because that's one of my favorite parts about this. So the training data that we came up with at first, because we're looking to scale this out across languages, so there's an API that Google has. It's the Google Vision API, and it'll take pictures, it'll take photos, and it can give you the emotion associated with a photo. But that doesn't really help us with text. So what we needed was a way to link up text to a photo. So what we did was we went to YouTube and we found videos that had really reliable transcripts, like TED Talks, things like that. And they had them in various different languages. And so we scraped those videos, and that gave us that link from text to still image. And we actually ran that through the Google Vision API, and that was just sort of our base training set that we started with. It's not especially clean, but there are a lot of things that there are a lot of dials we can tweak in terms of how often we're scraping, how many images we're scraping out of there and when, and how we're cutting up those transcripts. But that's essentially, in order to get something up and running very quickly, we automated a lot of that.
Okay, thank you. So how accurate the system is, what's the biggest challenges you see?
Yeah, I mean, that's a difficult question because it depends on your training set. And we know that we have a pretty dirty training set right now, so it's really hard to judge accuracy. I think that's a point that we'll get to later. I mean, it's definitely accurate enough to flag things that look suspicious. I mean, it's definitely useful, but we really haven't done too sophisticated analysis yet. That's, I think, in our motorcycle phase.
Okay, just give the last comment. Since you give example how to convert the text to two numbers, for now, you can use the word embedding. It's a technique which you can convert the text, the words, to the semantic domain. So basically, you don't have to carefully select the features. So you can dump out the text to convert it to the semantic domain. So each word convert to a bigger vector. Usually it's 300 or 400. And then you can do the sentiment analysis afterwards.
Yeah, I mean, I think there's a lot of different approaches with using different language models. I think my goal here was really just to say that you don't, there are some really cool things you can do, but you don't have to. Even just a really simple term frequency vector can still be very useful. But yeah, that's definitely an approach that would make sense.
Any other questions? Anyone? Thank you.